Hi, my name is Tony Lecca. I'm a 30-year veteran in the fire service. I spent 21 years on a heavy rescue company in Waterbury, Connecticut, and I'm the designer of the TL9 stabilizer.
Hi, I'm Paul DiBartolomeo. I have over 20 years in the fire service as both a volunteer and career firefighter. I work for the New York City Fire Department, assigned to Ladder 28 in Manhattan. I assisted Tony with some of the development and the testing of the TL9 stabilizer. The TL9 is a stabilization device used in conjunction with your hydraulic spreader to enhance speed and efficiency when performing a lift. It was specifically designed to facilitate lifting stability, thus increasing safety throughout the operation.
The inspiration behind the TL9 was very simple. I wanted a quicker, more efficient, and safer way to incorporate a tool that anybody on the fire ground knows how to use. That was the inspiration behind the TL9. Construction features of the TL9 stabilizer. There's a 6" by 6" 1/2 inch thick base plate. The base plate's constructed of AS36 steel, as are the gussets and the towers. Towers are 4 inches tall, 2 inches wide, with a 1 inch slot that allows the roll pin to travel. The roll pin's constructed of 5/8 inch thick stress-proof steel, tested to 50 ton as well. The towers have been tested for lateral stability to 15 ton with 1/8 inch of deviation. At the front of the tool, we have a piece of 5/8 inch square stock. This serves the purpose of allowing the tip to not travel past the front of the plate. There's also a milled slot at the rear of the stop. This allows the tip to drop into place and lock the tool.
So I'd like to talk a little bit about some safety considerations when using the TL9 stabilizer. As with any rescue incident or training evolution, you're ultimately going to be governed by the rules set forth by your department as they pertain to PPE. We at T&J recommend at a bare minimum that you have a helmet, long sleeve shirt, long pants, safety shoes, extrication gloves, and eye protection. And we cannot overemphasize this enough. When using the TL9 stabilizer in conjunction with a lift, proper cribbing techniques must be adhered to at all times. All right, so now we're going to give you an operational overview of the TL9 being used in conjunction with your hydraulic spreader. The load is going to remain in contact with the tip of the spreader's upper arm. The load is going to be transferred through the tool to the lower arm, which is securely positioned in the TL9. The load will ultimately be transferred into the ground. As our lift progresses, the tip of the lower arm begins to contact the limit pin. The pin will continue to rise throughout the lift until it reaches the top of the towers. At this point, our tool is open at about 70%. The limit pin will apply slight pressure to the lower spreader tip, which locks into the milled slot, and subsequently will lock the tool into place. For many of you, the thought of using your hydraulic spreader vertically may seem unorthodox. But in reality, we've been using the tool in this manner to perform modified dash lifts and door press maneuvers for over 30 years. Historically, rescuers rely on airbags or jacks to perform a lift of this nature. Both are perfectly acceptable, but they each have inherent disadvantages. Airbags are time-consuming to set up for even the most experienced rescuer, and their rated capacity and stability diminish as lift height increases. The jacks most departments carry are limited to 2.5 to 3 ton, which makes them less effective for larger vehicles such as SUVs and small trucks. The beauty of the hydraulic spreader is that it allows for a quick and powerful lift that is consistent throughout the operation, allowing for lift heights in excess of 20 inches. The problem with the spreader prior to the TL9 was minimal contact surface area with the ground on the lower tip and limited lateral stability. These two factors combined created a very unstable operation and often resulted in catastrophic system failure. Incorporating the TL9 into this operation significantly increases contact surface area, as the load is transferred to the 6x6 base plate and ultimately to the ground. In addition, the towers and the traveling limit pin lock the tool into the device, increasing lateral support. When performing a lift with the TL9, we highly recommend that you lift from the long axis of the vehicle. The long axis of the vehicle would be along the rocker panel. This is going to increase our footprint during the lifting operation. The short axis of the vehicle would be either front or rear, but the space between the tires. So we're going to recommend that you lift from the long axis whenever possible. Lifting from the long axis provides a wider footprint, which is going to increase stability. What's even more significant is as I lift from the passenger side here, this side of the vehicle is going to raise, but the tires on the opposite side of the vehicle are going to remain in contact with the ground, creating friction and preventing the vehicle from moving uninspectedly. A similar lift from the short axis is going to be inherently unstable. As we start our lift, the two front tires are going to come off the ground, significantly reducing our overall footprint. Our footprint is mainly going to consist of the 2-inch spreader tip. If this car is sitting on a road that's sloped in any manner, as the tires come up off the ground, the car is going to try to find its neutral and will likely topple the lifting device. Later in this video, we are going to discuss and demonstrate proper techniques for lifting off the short axis with the TL9 stabilizer. Prior to performing our lift, we must stabilize the vehicle opposite our lift. We accomplish this by chocking the wheels to prevent the vehicle from rolling and placing step chocks underneath the A and C posts to prevent the vehicle from sliding out or further compressing. Doing so will also aid in the lifting process, as the step chocks actually create a fulcrum, thus enhancing our lifting efforts. Prior to lifting, we must ensure we have sufficient cribbing in place to properly stabilize, chase, and eventually capture our load following our lift. We cannot stress this point enough. The most important part of any lifting operation, regardless of the lifting device, is proper cribbing. The rule of thumb throughout the fire rescue industry is lift an inch, crib an inch. This is of the utmost importance when using the TL9 in your hydraulic spreader. We must ensure, as with any lift, that the load is being closely followed while in motion and positively captured once we reach our desired lift height. Next, we select a point along the long axis to perform our lift. Generally, we choose an area forward of the B-post to account for the weight of the motor. A good landmark to line up on is the door handle. We attach the spreader to the TL9 by sliding the bottom jaw into the unit beneath the traveling pin, ensuring that the tip makes contact with the forward stop. We can then use our spreaders to steer the TL9 to the lift point beneath the vehicle. Slowly begin opening the spreader until the upper tip makes contact with the frame rail or rocker panel. Once we've made solid contact with the upper jaw, communicate with the members cribbing the load and confirm they are prepared for lifting.
Ready to lift. Ready. Lifting.
Slowly begin opening the spreader and begin lifting the load, maintaining a pace that allows the cribbing to keep up. Once you achieve your desired lift height, ensure the load has been positively captured with cribbing and lower the load.
Lowering the load.
Once the load is captured, you can remove the spreader and the TL9 in order to increase your opening for victim removal. As we said earlier, we strongly urge rescuers to lift from the long axis of the vehicle, but we realize there will be times when this is not possible. There will be instances where you cannot access the long axis. For example, if the car is in a tight garage which prevented access to the sides of the vehicle, we would be forced to lift from the short axis. In doing so, we must remember that our footprint is going to be considerably reduced as the tires come off the ground. Once the front tires break plane, the vehicle will look to find its neutral and will likely move to the low side of the terrain. We must account for this during our size up and take actions to limit or prevent this motion. Most importantly, we want to crib the vehicle along the path of anticipated motion. This can be achieved by following the load up with a step chock placed perpendicular to the vehicle. In addition, we can position our spreader and TL9 in a particular manner to offset this motion. Once we size up the terrain and determine the low side, we can position the spreader in TL9 on the downside of motion. By offsetting the spreader, we account for the load seeking its neutral plane and will likely prevent any such motion.
Ready to lift? Ready? Ready. Lifting. Prepare to capture the load. Ready. Lowering the load.
From everyone at T&J Rescue Enterprises, we'd like to thank you for taking the time to watch our video and for investing in our product.
The TL9 was developed by firefighters for firefighters, and when used properly, it will reduce operating time, maximize efficiency, and also dramatically increase safety.
On behalf of Tony, John, and myself, and everyone at T&J Rescue Enterprises, thank you very much.